This is the Omni Analytics Group Gap Scan application. This is sort of an interesting application where it prototypes one of our data science methods that we've created in order to try to guess the ideal number of clusters for a given data set. So what it does, essentially the algorithm looks for particular gaps in data points and defines those gaps as the way of determining the number of clusters in a particular data set. So this application lets you play with that. You can either choose to use the iris data, which is the default, or you can uncheck that and then upload your own data. You can then choose the number of variables, all the numeric variables you want to include. So I'm using the 4 from the iris data plus the 2 principal components. And then you select a label variable, which in this case is species. You can then choose a couple different methods of clustering. One is quantile and one is mean. We'll stick with quantile, and you can adjust the quantile from between 0.9 and 0.999, depending on how many clusters you want to kind of bias the algorithm towards. When we're ready with the parameters, we click compute, and what we get over here is an illustration of the tour. So what happens is it creates a tour through the data, kind of a path through the data set. In this case, we're plotting sepal length versus sepal width. We can see that the clustering solution appears to have found 3 different clusters, but it's really, the algorithm is mostly grouping into the first or the second cluster with just 1 point in the third. And it determines that based on the gaps. And we can actually see a histogram of those pairwise distances. So there's a few major outliers here, which ultimately represent the gaps in the tour, which indicate the number of clusters that we have. We can uncheck the show path option. If we wish to see the raw data, check it again, it'll redraw it, or we can change the variable. So maybe we want sepal petal length versus sepal width, or petal length versus petal width, and that works fine too. And we can see the clustering solution seems to be doing a pretty good job of determining the separation between the groups. And that's our gap scan application.